आईआईटी मेंस 2017 का एग्ज़ाम संपन्न हुआ। ये बुकलेट जेईई मेंस की मेरे हाथ में है। क्वेश्चन का जो पैटर्न और लेवल है, जैसा हमने पहले से ही आप लोगों से डिस्कस किया था, सेम वही है। ये बुकलेट जो मेरे हाथ में है उसका कोड ए है। इस बुकलेट का क्वेश्चन नंबर 1 देखिए आप। A man grows into a giant such that his linear dimension increases by a factor of 9. Assuming that his density remains same, the stress in the leg will changes by a factor of this. आप यहाँ पर देखिए, एक मैन है। अगर हम स्ट्रक्चर इस तरह से किसी कंसीडर करते तो इस स्ट्रक्चर में आप अगर इसका लेंथ ग्रो करता है तो एक क्रॉस सेक्शनल एरिया क्या करेगी, डिक्रीज करेगी। क्रॉस सेक्शनल एरिया डिक्रीज करेगी और हमको कैलकुलेट करना है स्ट्रेस। क्वेश्चन में दिया है कि डेंसिटी इसकी चेंज नहीं करती है। अगर डेंसिटी चेंज नहीं करती है तो स्ट्रेस होता क्या है, स्ट्रेस इज इक्वल टू W by A। W इज वेट, तो W इज इक्वल टू mg by A। m इज द मास ऑफ द मैन एंड m is equal to वॉल्यूम इनटू डेंसिटी। वॉल्यूम कितने के इक्वल है, A इन एरिया इनटू व्हाट, लेंथ मल्टीप्लाइड बाय d। m is equal to ALD, तो स्ट्रेस कितने के इक्वल हो गया, स्ट्रेस दैट इज इक्वल टू ALD upon A। It means here d is constant, so stress is directly proportional to what? Stress is directly proportional to length. So we can say here the linear dimension increases by a factor of 9. If linear dimension increases by a factor of 9, then stress will also increase by 9. Also increase by 9. In here option is given 9, 1 by 9, 81. 1 by 81. So option 1 is correct. Option 1 is correct. Option 1 is correct. In question number second, the question number second belongs to motion in a straight line. Here given question is, a body is thrown vertically upward. Which one of the following graph correctly represent the velocity versus time? बॉडी को हम थ्रो करते हैं वर्टिकली अपवर्ड डायरेक्शन में, तो मोशन कैसा, स्ट्रेट लाइन और मोशन अंडर ग्रेविटी। वेलोसिटी और टाइम के बीच का ग्राफ चाहिए हमको, हमें लिखना पड़ेगा एक इक्वेशन वेलोसिटी और टाइम के बीच की। तो v is equal to u minus gt when time t is equal to 0, when t is equal to 0 v is equal to u, and if we discuss about this equation, what will be the nature of the graph? This equation is like y is equal to mx plus c, y is equal to mx plus c. So graph will be straight line and have negative slope. In option first we see that at time t is equal to 0 velocity v is equal to 0. So option 1 is not correct. In option second, if we see in option second, here time is decreasing, so graph is not correct. Option second is not correct. Option 4, if you consider about option 4 is a graph between speed and time, so correct option will be 3. Option 3 will be correct. Option 3 will be correct. Option 3 will be question number 3. A body of mass 10 to power minus 2 kg is moving in a medium and experience a frictional force F is equal to minus of kV square. Frictional force is given. F is equal to minus kV square. Its initial speed is V naught. Initial speed is V naught and V naught is equal to 10 meter per second. If after 10 seconds its energy is, after 10 seconds, t is equal to 10 seconds, its energy is, kinetic energy is equal to 1 by 8 of mv naught square. We have to find the value of k. हमें k की वैल्यू बतानी है. This question is based on work energy theorem. Here, frictional force do work at the particle, due to which its velocity decreases, and due to decrease in this velocity, kinetic energy will increase. If kf is equal to 1 by 8 mv naught square, it means the final kinetic energy is 1 upon 8 mv naught square. If we assume here the final velocity is vf, then what will be the value of vf? The value of Vf can be find final kinetic energy, and kinetic energy after 10 seconds, half of m Vf square, that is equal to 1 upon 8 of mv naught square. mv naught square, m से cancel, this is 2 4 जा 8. Vf is equal to V naught by 2. It means velocity of the particle after 10 seconds decreases from V naught to V naught by 2. So here we can calculate the final velocity. Final velocity can be calculated by another method. F is equal to minus of kV square, and by Newton's second law of motion we can write F is m dv by dt, that is minus of kV square. dv by dt is that is equal to minus of k by m into v square, where m is equal to, here m is equal to 10 to power minus 2 kg. Then we can write dv by dt, that is equal to minus of k upon 10 to power minus 2 into v square. We can write here dv by v square, that is equal to minus of 10 to power 2k into dt. In time interval 0 to 10 seconds, velocity changes from v naught to v naught by 2. So here, to calculate the change in velocity in time interval 10 seconds, we integrate this equation. We integrate the equation first. We can write here integral dv by v square, that is equal to minus of 10 to power 2k integral dt. We can write it as dv by v square as simple integration, that is minus of 1 by v, and in lower limit of the integration is v naught and upper limit is v naught by 2. We can write it as minus 1 by v integration from v naught to v naught by 2, that is equal to minus of 10 to power 2 k into 10। इंटीग्रेशन कहां से कहां तक है? 0 से 10 तक, 0 से 10 तक। इट्स वैल्यू कम्स आउट टू बी माइनस माइनस प्लस, दैट इज 1 upon of v naught by 2 minus of 1 upon of v naught, that is equal to 10 to power 3k. 10 to power 3k. We can write 2 upon v naught minus 1 by v naught, that comes out to be 10 to power 3k. 1 by v naught, that is equal to 10 to power 3k. And v naught is equal to, v naught is 10 meter per second. V naught is 10 meter per second. We can write k is equal to 1 upon 10 into 10 to power 3. That is 10 to power minus 4. 10 to power minus 4 kilogram per meter. And here the given option is in the given option number 3 is correct. So we can write option 3 is correct. Option 3 is correct. Option 3 is correct. Option 3 is correct. Question number 4. A time dependent force F is equal to 60. Time dependent force F is equal to 60 acts on a particle of mass 1 kg. Mass of the particle is 1 kg. Mass of the particle is 1 kg. If the particle starts from rest, the work done by the force during the first 1 second. This question is also based on work energy theorem. Work done at the particle is equal to change in kinetic energy. Here, initially particle is at rest. If you want to calculate the change in kinetic energy, we must calculate the velocity of particle at 1 second. Here, a relation is given between force and time. F is equal to 60. F is equal to 60, and we can write by Newton's second law of motion, F is equal to m dv by dt. F is equal to m dv by dt, that is equal to 60. M is equal to 1 kg. So dv by dt, that is equal to 60. dv is equal to 60 dt. 60 dt. Initially particle is at rest. So initial velocity of particle is 0. And v here, if we assume the final velocity is v, then change in velocity between 0 to 1 second can be written as integral dv 0 to v, that is equal to integral 60 dt 0 to 1. Integration of 60 dt, that is 6 t square by 2, 0 to 1, 0 to 1. Its value comes out to be 3. So V is equal to 3 meter per second. V is equal to 3 meter per second. So change in kinetic energy we can calculate here, change in kinetic energy, and change in kinetic energy is equal to work done by this force. We can write W is equal to डेल्टा के हाफ m v स्क्वायर माइनस हाफ ऑफ m u स्क्वायर. Here u is equal to 0 and v is equal to 3 meter per second. So W is equal to half m means 1 kg into v square. V is 3 into 3 का square, that is 9. So W is equal to 9 by 2, that is 4.5 joule. Here in the given option number first is correct. Option first is correct. The moment of inertia of a uniform cylinder of length L and radius R about its perpendicular bisector is I. What is the ratio L by R such that the moment of inertia is minimum? Here we have a cylinder of length L and radius R. Length L and radius R. This is the cylinder of uniform, and here given quantity is the moment of inertia I of this cylinder about the perpendicular bisector. The value of I about the perpendicular bisector is I is equal to m r square by 4 plus m L square by 12. We have to calculate the value of L by R. The value of L by R when I is minimum. I is minimum. For the minimum value of I, di by dl should be equal to 0. If we differentiate this equation with respect to L, we have di by dl that is equal to m by 4 is common, that is 2r dr by dl plus twice of ml upon 12, and this is equal to mr by 2 dr by dl plus m by 6l. This is the equation number first. This is the equation number second. Volume of the cylinder is V is equal to pi r square L, and for a given length and radius, volume of the cylinder is constant. If we differentiate this equation third, we have 0 is equal to pi into 2r dr plus pi into r square dl. We can write it as twice pi r dr, that is equal to minus of pi r square dl. पाई से पाई कैंसिल हो गया, आर से आर कैंसिल हो गया, डी आर बाई डी एल that is equal to dr by dl, that is equal to, we have minus of r by 2, minus of r by 2 This is the value here, twice pi r, here one term is left, 2 pi r l, 2 pi r l. We can write it as dr by dl is minus r by 2l. This is the equation number 4. Put this value in equation second. Di by dl, that is equal to m r by 2 into minus of r by 2l minus of r by 2l plus m by l, m l by 6. This is equal to 0. This is equal to 0. For minimum value of I, minimum value of I, di by dr, that is equal to 0. So we can write m r square upon 4l minus plus ml by 6, that is equal to 0. Or we can write it as r square by 4l, that is equal to l by 6. So r square by l square, that is equal to 4 by 6, or r by l, that is equal to root of 2 by 3. We have to calculate l by r. So l by r is root of 3 by 2. In the given option, for the minimum value of I, l by r is root 3 by 2, root 3 by 2, 1, and option number 4 is 3 by root 2. So option first is correct. So correct option is root 3 by 2. Correct option is root 3 by 2. Correct option is root 3 by 2. Option first is correct. So option first is correct.